In this episode, we're going to look at who hears a broadcast. We'll show you some of the packets as they travel across the network, and then we'll talk about the concepts that are happening along the way. We're going to use a 24 port switch that's fully populated. All the ports are in use. We're going to observe broadcast traffic in a VLAN implementation, and then we have some reflection questions we're going to discuss. We'll be discussing how to observe that broadcast traffic in a VLAN implementation. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Who hears the broadcast? I have our packet tracer lab opened up here. On the left side, this is our work area. We can see our topology. This is where we're going to be interacting with our devices. On the right side, I have our instructions. The bottom right is the actual packet tracer activity window that opens up when we open up packet tracer. The upper right is the Word document of those instructions. There are several questions we have to go through and answer in this exercise. This allows me to type my answers in the Word document and save it. In this lab, what we're going to do is we're going to look at broadcast traffic and see how that works with VLANs. And then once we're done with that, we're going to go and look at some review questions. Here we have our topology. We have a 24 port switch in the middle. We have 24 PCs hooked up to each one of those ports. What we've done here is used all the ports, and we've created some VLANs in here. We have VLAN 10 up here in the upper right corner. We have VLAN 20 in the upper left corner. And the bottom middle, we have VLAN 30. All of these PCs are in the corresponding VLANs. Step 1. Click PC 0 and click the desktop command prompt. Right here is PC 0 at about the 7 o'clock from the switch. Go ahead and click on that. Go up here, click on desktop, click on command prompt. We're going to do a ping, and then enter in the command ping space 192.168.1.8. What this does is it shows us that the system works, that we can ping across the networks, we can ping other devices. On to step 2. Generate and examine broadcast traffic in a VLAN implementation. I'm going to go ahead and close PC01 window. Here. Step 2A, switch to simulation mode. What we're looking for down here is we have the real-time in the simulation button. It's in the bottom right corner of the main packet tracer window, about the center middle bottom of my screen. You see where it says real-time simulation? Go ahead and click on simulation right here. Opens up our simulation panel. We'll be able to watch our PDUs travel across the network in this window. Step 2B, click the Show All None button. The event list filters visible events should say none. What we're looking at right down here is right above where we clicked on simulation. We're looking for what says event list filters visible events, and it should say none. If you click the Show None button right above the simulation, it will list out all the events, and it will show all the events here in the simulation panel that packet tracer can track. What we want to do is have it say none. So I'm going to go ahead and click on the Show All None button again. Now it says none. Step 2C, edit the filters and check the ICMP checkbox. Right next to the Show All None button, we have the edit filters. Go ahead and click on that. We have 3 tabs across the top. Make sure you're on IP version 4 and put a check mark in ICMP. Ping is part of ICMP. We're going to use ping to understand how these VLANs and broadcasts all work. We want to see those events. So go ahead and make sure ICMP is checked and close that window. Step 2D. Click the Add Complex PDU tool. This is the open envelope on the right toolbar. Here on my computer, what we have is we have the file edit options main menu up there. It's not that row. The row below it that has the printer icon, it's not that one. It's the 3rd row down here. It's the open envelope. It's on the right side here. It's an open envelope. That's what it is. It's an envelope, but then the top has been flipped up with a little plus sign. If you put your mouse over that and pause for a second, it's going to say add complex PDU. Go ahead, click on that. And then when you drag it into the main work area, it changes to an envelope with a plus sign. That's how you know that you can add in this complex PDU. That takes care of step 2D and 2E. Onto 2F. Click PC0 to serve as the source for this test message and create complex PDU dialog window opens. Once again, I'm going to click on PCU while my icon looks like this giant envelope. Opens up the create complex PDU window. Enter the following values. Destination IP address. Destination IP address is a special IP version 4 address. 255, 255, 255.255. 4 255s. Think about the 255. The 255, if we convert that to binary, is all ones. That gives us 8 ones. And we have 4 sets of those. That gives us 32 ones. Our IP address is all ones. That's special. And it's a broadcast. What happens is the device sending it out sends it out, the switch gets it, and then it propagates it out to all the other devices on its local area network except for the port it came in on. Let's go ahead and enter in our information. Destination IP address, once again, is the broadcast IP version 4 address. That would be 4 255s. Then we have a sequence number of 1. And then down towards the bottom here, we have underneath simulation settings, we have the one-shot time. We want to set that to 0 seconds. At this point in time, we can go ahead and click create. Oh, no, we got a question yet here. Within the PDU settings, and so make sure you still have your create complex PDU window open, the default for select application is ping. What we're looking at here is this center grouping called PDU settings. The select application, the default is select ping. That's what's chosen for us automatically. What are at least 3 other applications available for use? If we come over here, click on the drop down here, we can see that these are all the other applications that Packet Tracer supports that we can send PDUs for. And so instead of just testing ping, we can go through and test FTP, HTTP, POP, SSH, Telnet, and there's even an other. And so there's about a dozen different things we can go in there. And our question is, what are at least 3 other applications available for this use? Well, there was FTP, HTTP, and SSH. At least 3. Like I said, there was probably close to a dozen there. Now we can go ahead and click on Create PDU. I click on that. The test broadcast packet now appears in the simulation panel event list. It also appears in the PDU list window. The PDU is for scenario 0. You get the PDU list window up, and that will list all the PDUs we have going across our network. This is the method I use to get it up. Down here in the bottom right of our main Packet Tracer window, there's this little bar. It's almost in the center of my screen right here. It looks like a little triangle pointed to the left. If you go ahead and you click on that, it opens this little window up. On this window here, what I do is I click toggle PDU list window, and it opens up this window right here. It's another window, and it shows us what PDUs we have going across our network. Right now, we just have 1 PDU, and it's in progress, and it's destination for 255, 255, 255, 255. It is that broadcast IP version 4 address. Click the capture forward button twice. Capture forward button is down here towards the bottom of my screen. It is basically almost underneath PC0. If you follow it down, it's in the blue line. It looks like a triangle pointed to the right with a line. If you mouse over it for a second, it says capture then forward. Our instructions were to click it twice. Go ahead and click it once. We can see that the PDU went from PC0 to the switch. And then if I click it a second time, it forwards it out to all the other devices on my local area network. What happened here? Why didn't it go to all 23 devices? Because once again, that switch forwards it out all all available ports on that local area network except for the port it got it in from. We got 24 ports that all have devices hooked up. Comes in one port, it sends it out 23. But it only sent it out to this group of IP addresses down there. Why did that, or this group of PCs down here, why didn't everybody get that? Well, it's the idea of virtual LANs. Just like you have a local area network set up in your accounting area or in your business, and you have a local area network at home, those two don't communicate with each other because they're on separate LANs. They're with separate equipment. What we can do is create these virtual LANs inside of a switch. We can take the individual ports on a switch and say, you belong to one VLAN. Then you can take some more ports, add it into another VLAN, add it into a third VLAN. How many ever VLANs you need, you can add the ports into those VLANs. And then, because those are separate local area networks, they have different network addresses, they have probably different functions, different security levels on your network, they cannot communicate with each other through the switch. We would need to add in some more equipment, like a layer 3 router into the scenario. But right now we just have one layer 2 switch. That information can't change VLANs with just the switch alone. And that's what happened here, was the PDU came in from PC0 and went to the switch, and then the switch sent it out to all the other devices on the VLAN. And the VLAN here was VLAN 30, and we can see that only devices on VLAN 30 got this green PDU envelope. Yours is probably going to be a different color. Meanwhile, the other 16 devices on VLAN 10 and VLAN 20 did not get any of that broadcast traffic. And now our question here is, what happened to that packet? That broadcast packet was sent to all devices on the same LAN, on the same virtual LAN, which is VLAN 30 in our example. The broadcast packet was sent to all N devices on the same VLAN, which is VLAN 30. Repeat this process for PC 8 and PC 16. What I'm going to do is I'm going to delete this PDU. It's up here, it's selected. Make sure it says scenario 0 right here in the bottom right. If you don't have this window right here, it's clicking on this button. Click on this button right here below the simulation. It's sort of like just a little line going up and down, gray line with that triangle pointing to the light. If you click on it, it opens this up. Make sure it says scenario 0. You can go ahead and click delete, and that deletes our PDU. Now let's go ahead and repeat this process for PC 8. Up here, click on create complex PDU. Click on PC 8, which is at about the 4 o'clock in my diagram. Enter in our information. IP address was the broadcast address again, which was 255.255.255 for 255s. Sequence number is 1, and the one-shot time is a 0. Create that PDU. Here I did have a green envelope identifying it that we did create a PDU right where it's at. Also in our simulation panel, we can see that we have our PDU created right here. I'm going to go ahead and click the capture and forward button once. The PDU travels to the switch, and then the switch forwards it out to all devices on the same VLAN except for the port it came in on, which means all devices here got it. All devices on VLAN 10, except for the one it got it from, received that packet. None of the other PCs on the other VLANs, VLANs 20 and VLAN 30, they didn't receive any of that broadcast. I'm going to go ahead and delete this PDU again. Click on delete, and let's go ahead and repeat this process for PC 16. Up here, click on the add complex PDU. Here's PC 16 at about the 10 o'clock from the switch. Come in, enter in our destination IP address, 4255s, set our sequence number of 1 and the one-shot time of 0. Click create PDU. I have a brown PDU this time. What's your guess on what's going to happen? My guess is PC16 is going to send this broadcast to the switch. Then the switch is going to forward that broadcast to all other devices on the same VLAN, except for the port it came in on. Which means all of these PCs here, except for the one where that broadcast originated from, will receive that broadcast. None of the rest, VLAN 10 or VLAN 30, is going to receive that broadcast. Okay, I'm going to go and click on the capture and forward button once, sends the PDU to the switch. Click the capture and forward button a second time, and there it goes. It broadcasted out to all the other devices on the same VLAN. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Our reflection questions. Question 1. If a PC in VLAN 10 sends a broadcast message, which devices receive that? If a PC on VLAN 10 sends a broadcast, and that's over here, this is VLAN 10, one of these PCs sends a broadcast out, what's going to happen? Well, it's going to go to the switch, and then the switch is going to forward it to all the other devices on the same VLAN. So which devices receive it? All N devices on VLAN 10. Reflection question 2. If a PC in VLAN 20 sends a broadcast message, which device receives it? Well, that's what we just did right here, is on VLAN 20, PC16 sent out a broadcast, and all the other devices in VLAN 20 received it, none of the other devices. So which one receives it? All N devices on VLAN 20. Reflection question number 3. If a PC in VLAN 30 sends out a broadcast message, which device receives it? Well, that was the first one we did down here. This is VLAN 30 down here. PC 0 sent out that broadcast. All the other devices in VLAN 30 received it. And the answer to our question here is all devices. Now let's keep it consistent. All N devices on VLAN 30 received it. Question number 4. What happens to a frame sent from a PC in VLAN 10 to a PC in VLAN 20 or VLAN 30? So we're going from VLAN 10 to VLAN 30. I'm going to come back here to our work area. I'm going to delete this PDU. Once again, that's down here in this bottom right window. Make sure scenario 0 is selected. Go ahead and click delete. And question 4 is talking about sending a broadcast, right? Sending a frame, so it's unicast. So it's going from PC 15, we'll pick out 15 in VLAN 10, down to, let's say, PC 7 down here in VLAN 30. So VLAN 10 to VLAN 30. What's going to happen? Well, let's go ahead and test this. Up here, next to the create complex PDU, there's also the add the simple PDU. What that is just a simple ping. Go ahead, if you click on that, click on PC 15, and then click on PC 7. That's all you have to do is create a point-to-point, a unicast ping. Is click on the source and then the destination, and it creates it. We can see that we have a PDU in our simulation panel. In our PDU list window, we now have a new PDU there. I'm going to go ahead and click the capture and forward once. And notice it took a couple seconds, but it aired out. And all of a sudden we have this red X flashing up here. And it's saying, I can't deliver it. I can't identify that PC on my network. I can't find it, so I can't deliver it. Now, what was the reason? Because they're on different VLANs. This is just like having two separate physical switches. How do you get that information from one switch to another switch? How do you get that information from one network to another network? You're going to have to add a router in there, a layer 3 device that does routing. Right now, we only have one layer 2 switch. It doesn't do any routing, and so it can't change VLANs. So what happens to that frame sent from VLAN 10 to VLAN 30? Well, the broadcast packet will be dropped, and once again, another name for dropped is deleted, but we use dropped because they are different VLANs. Question 5 about the reflection questions. Which ports on the switch light up if a PC connected to port 11 sends a unicast message to a PC connected to port 13? Oh, okay, so now we're talking about the port. If port 11 sends a unicast message to port 13, the end device is connected to those, what's going to happen? Well, we're going to have to do a little bit of detective work. And for me, the easy way of doing that is if I come over here in our work area, I click in it to make sure this window's activated, and then I put the mouse over the switch and I let it sit there, and I pull my hands away, and it gives me a list. And this is very similar to the show IP interface brief command. And what we can see here is the link up or down. We can see what VLAN it belongs to, and then it gives the IP address and MAC address after that. But now we can now actually go and find out what VLANs these ports are. And once again, we are looking at port 11 and port 13. Going down the list here, we can see that Fast Ethernet 0/11 is up, and it belongs to VLAN 20. We can see that Fast Ethernet 013 is also up, and that belongs to VLAN 20. 11 is in VLAN 20, 13 is in VLAN 20. They will be able to communicate, they'll be able to send data, and they will light up because they are in the same network when you try to send that data. And the answer to number 5 is they will light up because they are in the same network. Reflection question 6. Which ports on the switch light up if a PC connected to port 2 sends a unicast message to port 23? Now we're looking at going between port 2 and port 23. Once again, I'm going to come over here. I'm going to click, make sure this window's activated, put my mouse on the switch, and just let it sit there. And we are looking for port 2 and port 23. Port 2 is in VLAN 30. Port 23 is in VLAN 10. So we're going from VLAN 30 to VLAN 10. What's going to happen? They're in different VLANs. They can't communicate. And so that packet is going to be dropped. Nothing's going to light up. They're going to drop that packet because they are in different VLANs. Answer for our question here is the lights will not light up. The broadcast packet will be dropped because they are in different VLANs. Reflection question 7. In terms of ports, what are collision domains on the switch? When we talk about the ports on the switch, and in our example, we have a 24 port switch, so we have 24 ports there. What are collision domains on the switch? Once again, remember, a collision domain is where a collision can happen. Typically, it has to do with duplex and sometimes speed. And what the switch does is it does a couple things to eliminate the switches. The switch only sends information out of port if it knows what MAC address is there. And so we cut down on a lot of extra traffic going across that connection. The other method here is the switch tries to get full duplex, meaning there's two paths for communication, one to send and one to receive. This is like a two-lane road. You drive down one side, the other people coming at you in the opposite direction, they have their own lane, and so you can pass each other successfully. You can get through that road pretty quickly. But what happens if that road, that two-lane road, goes down to a one-lane bridge at that point in time? Now all of a sudden you only can drive in one direction. Either you can go your direction or the other person can go their direction. Right? You can't both go at the same time because there's not enough room on that bridge. If both of you go at the same time, there's going to be a collision. There's going to be an accident. And lots of bad things happen at that point in time. Same thing with data, that if you're doing half duplex and you can only send or receive at the same time, and two people send, you're going to have a collision, and that traffic's not going to get through. And so what the cars have to do is one car has to wait. Well, that car waiting is now going to be slowed down and can't get to its destination as fast as it could have. And same thing happens when you do half duplex on the switch, is some traffic has to wait while the others, and that slows your throughput down. And the switch creates a collision domain for every port. So every port on that switch is a collision domain. On our 24 ports switch, we have 24 separate collision domains. Each port is a collision domain. And the answer to reflection question 7 here is each port is its own collision domain. Reflection question 8. In terms of ports, what are broadcast domains on the switch? When we look here and look at our exercise, we sent out several broadcasts. PC0 sent one out, PC8, PC16. They sent out the broadcast, and that broadcast then went to the rest of the devices in that local area network, in that LAN, in that VLAN. All the other devices and different VLANs didn't hear that. And so each broadcast domain is a separate VLAN on a switch. And the answer to our question here is each VLAN is its own broadcast domain. That was Packet Tracer Lab 3.1.4, Who Hears the Broadcast? It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.